Hey, so this project is already disassembled, so I'm just filming like the video I got on the computer, and I will explain about it. And generally, this is just a forward and backward device that I had, and I use it to measure precision of stepper motors. What we've got here is the stepper motor connected here on this with this belt to move this black block back and forward. We got here like the linear guides, and when it moves, it is connected to this encoder on the silver in the one in the back. This is like a CNC machine encoder, and it's connected to it, and it is very precise. So he will measure the linear motion of this block. And now we've got here 3 microcontrollers that works together. It's all in the Arduino framework, so it's pretty easy to do, and it's also like robust and works great. And we got here a Teensy board that is very fast, like 600 megahertz clock, to measure the encoder sensor measurement. Here we got an Arduino that will drive the motor. Of course, it will send it to the stepper. This is the stepper driver, an industrial one, and he will send a movement command to the stepper, and the stepper will the driver will move the stepper, and when it will move, the Teensy will pick up the encoder measurements. And the Teensy have to be fast because it's working in interrupt mode, so every time you got to insert to the interrupt, record fast the movement and go out of the interrupt to continue to wait for the next interrupt. So it have to be faster than the Arduino, and of course it is. And the third microcontroller is just to record data to the PC. We got here the micro, and the micro record the movement, and it send the movement to the PC to an Excel sheet, and that way we can record the measurement. And let's start to see it moves. Okay, so every time there's a little bit of movement to compensate for backlash. So right now it's going to be like a little movement, like 200 steps, and to compensate for backlash, and then a movement of 8,000 steps. So again, backlash just to compensate on it, and then result are recorded to the Excel sheet. So we're just going back and forth, and every time it will record how many steps it has achieved. It already knows how much it should do, and then like this it will have the error, and we can do it with different speed, different motors, and check for a motor with which speed it will perform better. And of course we can change the macro stepping and check the precision, and of course different motors, we can exchange to different motors and see which one performs better. And that's it. Generally, at this time that I did this was the most precise sensor that I had to measure a stepper motor. Years after, I got a magnetic encoder that was pretty much precise as this one, because here we got like the rotation to the linear, and the backlash and tolerances. So it's but it's less preferred. It's like much preferred to just measure a rotation with a rotating encoder, not a linear one. But at this time, like, this is what I have, and it actually worked pretty great. That's it.